Okay, so today we are covering 9.5, how to graph a linear equality in the coordinate plane. Tonight's homework, you're doing 9.5, page 419, number 1 through 33 odd, and number 5 through 41 all. All right, to graph linear inequalities in the coordinate plane. So here we go. Let's just start out with, now, as you guys are writing your notes, it's going to start trying to teach you how to do Cornell Notes, where we're going to put this down. If you take a third of your paper, as you see right here that I did, or I guess a third, and I'm going to list the topic over here, and over here we're going to have questions, examples, just a better way to organize our notes so that when you go back to review it. So for this first example, I'd like to see you graph this on the number line. So if you have your 2/3 of a line of paper, it's going to be a little bit different than what you're going to see. And then I'd like to see you do it, show the example right here. So when we graph this on a number line, okay, you're going to put your number line to the right. And remember, we need two numbers, 0 and 3. And because it is less than or equal to, we're going to start with a solid point at 3, and we are going in the less than direction. Okay? We have one variable, so one dimension, and it's on, this is how we do it on a number line. In fact, you're going to write this on a number line. You can, and the next one you're going to do is, now let's do, or I could put my number line here. And next we're going to put x is less than or equal to 3 on the coordinate plane. Okay, so over here you're going to write your example right here. Okay, now my PowerPoint's not going to be over, well, it will kind of be over there, but it won't have the same format. This is just going to make your notes a little bit easier to read. Okay, so let's continue and look at the example. So you're going to need an x and a y axis. We've already done that part. You're going to need an x and a y axis. And now when we go to on the x-axis, okay, we're going to go to 3. 1, 2, 3. If I were to graph that, like if it were an equation, x equals 3, I'm going to remind you, we make a little table. Oops, it should be a y. We make a little table, and we choose our x's are always going to be 3, and in this case, we choose our y's. 1, 2, okay? So I put a point, and I go 0 across, 3 across 0, 3 across 1, 3 across 2. And as you see, we're going to get that line, right? Now, when you have a coordinate plane, this means everything less than 3 on this equation right here is everything less than 3, right? This is x equals 3 right here on the coordinate plane. However, what this really means is every point that's less than 3. So it could be this, because this is a point where the x is less than 3. It could be this point, because when I look at the x, it's less than 3. So there are infinite amount of points. There's a point here, there's a point here. These are all less than, if you go on the x-axis, if you check their x's, they're all less than 3. So the way that we show that is that we have to shade it. We shade everything less than on the x-axis, okay? And since the x-axis is here, we're going this way from our boundary line. We're going this way, right? shading everything less than the x. And there we have it graphed on the coordinate plane. This is the time where you get to get your colored pencils out. So go get them out. Usually in the class, I have some kids. Okay, again, I'll show you what y looks like. And again, I would like for you to be making your notes so that we're showing it here on the number line. And here, y is greater than -2 on a coordinate plane. Okay? So, when I draw my number line here, remember we have two numbers, -2 and 0. On the number line, I'm putting an open circle and I'm going in this direction. However, when we do it on the coordinate plane, first thing we have to do is look for y equals -2. So if I made that graph, I'm doing x, I'm doing y, our y's are -2, -2, -2, and we choose our x's. And so if I plot those points, right? As we begin to plot those points, I'm going to 0 across, down 2. 1 across, and we start to see that. Now, because it is greater than, it's going to look just like this. It's going to be a dashed line because it's not equal to. And where are the numbers bigger? Because this reads, this right here is y equals to 2, right? If you do a solid line. But once you do the shading to do y is greater than 2, than -2, then we have to look at on the y-axis where are the numbers. Here's -1, 0, 1, 2, 1, 0, 0, 1, 2, 3. Up here, this is greater than -2, 2, my y. So in this case, all of this would be shaded. And we still are labeling our x and our y-axis. Otherwise, we might not know the difference between it. Now, I'm going to show it to you with my PowerPoint, but I want you to start trying to do your formatting of y is greater than -2 over here, and then show the example to the right. So you can maybe start to create some Cornell Notes with your math. It makes things really easy to study with. So if you go through them at the end of the day. All right, so again, you're doing your 2/3. I would put, as you're doing this, let's pretend your line is here. I would put your, of course, if my coordinate plane could, let me try this, could move downward. Well, it's not going to be able to do it. So I would make your 2/3 of a line, or 1/3. Do your y. Y is less than or equal to 2 over 3x minus 1. And over here, this is where you're going to identify your information and then show it all on the graph. Remember, our m is 2/3. Our b is -1. Okay. And then we're going to put all of that. So first thing we have to do, our boundary line is y equals 2/3 x minus 1. So my m is 2/3, my b is -1, and I'm going to graph that. I'm going to start at the b at -1, and now I'm going to rise 2, run 3. Rise 2, run 3. Rise 2, run 3. Oh, thank you. rise 2, run 3. Or I can do negative 2, right? I can do negative, negative. And then now, here's where it's going to be. If it's less than or equal to, we do a solid line, okay? If it's less than or equal to or greater than or equal to, we do a solid line. Now, what I like to do in terms of the shading, there's a couple different things you can do. But what I tend to do, you can do a test point, but I actually kind of block this out, X term. This only works when you get Y alone. And so where is Y less than? I look for this on the Y-axis. Okay, here's my -1. So where are the numbers less than -1 on the Y-axis? They're down here, 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 right? This is a number line. Here's 0, here's 1, 2, 3. Here's -2, -3. So since these are the numbers that are less than -1, that is the side that I will end up shading. Okay? That is the side that I will end up shading. Another method would be to do what's called a test point. Oops. Okay, and a test point is you pick any point. Okay, we pick any point on the coordinate plane. So they're picking 0, 0. It's an easy point. I test it. If it makes a true statement, then that's the side we shade. If it makes a false statement, we shade the other side of the line. So in this case, as I substitute, 0 is less than or equal to -1. That is a false statement. 0 is greater than -1, so I have to shade the opposite side. Since that's not true, we shade the opposite side of the test point. So that's method number 2. One more time. How I figure it out is I just cross this out and I read it from the Y. Y has to be alone on the left. Y is less than -1. The numbers that are less than -1 on the Y-axis are all here. They're not here. So I do the ones where they are less than that -1. That is the side of the boundary line I shade. So now let's talk about how we draw our line. If it's greater than or equal to, if it's a solid line when we have this symbol. Now you can look at this. I tend to get kind of confused. I just know that if it's equal to, it's solid. If it's not equal to, like less than or greater than, then it's dashed line. The shading, again, I showed you the 2 ways that we can figure it out, but this is shading up. If you read from the left for solid line, and less than or equal to would be here. Pause the recording if you would like to. I add that. Why don't you make on your left column shading, and then on the other side you're going to draw this diagram. So another thing for your Cornell notes, you're going to draw shading. Oops, I moved the whole screen down. You're going to draw shading and lines, and then you can draw that box. Okay? Make it nice and easy. Okay? Pause the recording if you need to write that. We're going to keep moving on. Okay, so now it's your turn. It's going to be a tough one for you guys to show in the chat box. This has been my most challenging thing to teach so far. So, first thing we do, we always, now again, as you're doing your Cornell notes, let's do this. Let's erase this. We're still on that line. Now, if you get to the bottom of the page, you're just turning the page and draw another line. Okay? I guarantee you this will make your notes. Okay, so wait, what was it? Now I've forgotten what the y is greater than -3. So I'm going to write y is greater than -x plus 3. Okay. I don't know. Actually, this will probably work better. Okay. Over here, remember we're going to do m is equal, b is equal to. Okay? M is equal to -1, right? And b is equal to 3. We start on the 3. 1, 2, 3. And then we have to go down 1 over 1, 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 down 1 over 1. Or I can go positive 1 over -1. Now, is this line going to be solid or dashed? It says greater than, not greater than or equal to, so it will be a dashed line. Best thing about this is you don't really need a ruler when you're doing these dashed lines. Okay, make sure you have arrows. You've labeled your x and y axis. And now we have to figure out, you can either do a test point. So right below it, I'm going to just write it here. Y is greater than 3, right? We pretend temporarily. So where are the numbers on the y-axis greater than 3? Here, here, here. So that becomes the side that I shade. So now please make sure this is clear. Don't just make this one big scribble. You can use colored pencils, especially when we get to a system and you're using 2 colors. Remember, the other way that you could have done this is you could have picked a test point. If you're going to pick a test point, do that work right underneath the graph. Call it test point. You can take 0, 0. Okay? If I substitute that in, I don't have any room here. Let's see. 0 is greater than -x plus 3. 0 is greater than -0 plus 3. Is that a true statement? 0 is greater than 3? No. So that point is not the side that you graph. You graph on the other side of that boundary line. All right. Let's try it again. Okay, if our line is in standard form, I'm going to remind you, you have to graph in slope-intercept form. This is the only way you can find the graph. So this is our chance now, our last chance at learning how to graph using slope-intercept. So step 1, we have to get the y out. So we're going to, now again, I would probably do this all on the left side of my paper and have my column for the title of 4x plus 5y is greater than or equal to 10. But I don't have room to do that. So we're going to subtract 4x. And then we have to, I'm seeing a lot of problems with the graphing that when you divide, you have to divide all terms. Divide by 5, divide by 5, divide by 5. You can divide unlike terms. You can't add unlike terms. So then we get y is greater than or equal to -4/5 x plus 2. We identify our m is -4/5. Our b is +2. It becomes our starting point 2, and then I'm going to go down 4/5. Now, will this be a solid or a dashed line? should be a solid because it's it's greater than or equal to, right? So it's going to be a solid line. And then now that I know that y is alone, I can erase this and tell me y is greater than -2. So if y is greater than -2, that would be here on my y-axis. We're always just looking on the y-axis. So I'm doing a solid line and I'm shading above it. Okay, there we go. Okay, your turn. Get the y alone, pause the recording. Now let's check our work. Get the y alone. Divide all terms by 2. Now, this is very important. Notice I'm dividing an inequality by negative. That means we have to flip the term. Flip the term. Make sure you highlight that when you divide all terms. And actually, I'm going to go back a step. So when I'm dividing here and I realize I have to divide by -2, divide by -2, divide by -2, I have to flip that sign to be a less than. So then I get y is less than 3 over 2x minus 4. My m equals 3 over 2. My b equals -4. Now, if I temporarily, it's going to be a solid or a dashed line. Since it's only less than, it's going to be solid. And then, if I get rid of this, y is less than -4. So I'm looking for 1, 2, 3, 4. There's my -4. Where are the numbers less than -4 on the y-axis? Here. Okay, so that I'm going to be shading below that. Okay. So I'm starting at my -4. I'm going to rise 3, run 2, rise 3, run 2, rise 3, run 2. Or we can do negative over negative. It's going to be a dashed line, and we are shading below it. So your graph should look like this. Okay, let's keep going. Let's try one more. You guys try this one, and then I'll show you. Okay, let's check our work. Remember, we have to divide by a -3. That means all terms. Now be careful here. I don't like the way my PowerPoint does it, so I guess if you're not here and you're just watching it, I want you to remember it's -3, -3, and people that had graphing issues didn't graph that last number. So then I end up with y, I have to flip it around. -3. Y is greater than or equal to, oops, there it is. Okay, you should have had a solid line. Okay, it should be solid. I'm rising 4, running 3, rising 4, running 3, doing a solid line. And one more time, if I get rid of this and it says y is greater than -2, my numbers greater than -2 are here, so that is the side that we shade on. That only works if y is alone and is on the left side. All right. I think I'm going to, okay, let's just look at this one really quick because sometimes kids get really, so divide both sides by 2. Remember, we have to get our y alone. Now, they switch it right away. Move the y term over to the left. Divide both sides by 2. We always have to read from the left. Get your y alone on the left. It's not an option. So now I've got my m is 3 over 2, and my b, if there's nothing there, it's a 0. It's going through the origin. It's going to be a dashed line, and then where are numbers greater than 0, it would be above the point, the origin. So again, you could use a test point too. Can't use 0, 0. You're going to have to use something different. All right, the next way that they could potentially ask you this question is this a point? The way we figure that out, we substitute it in. If it makes a true statement, it is a point. If it doesn't, this is too much work. Don't graph it. If I give you something like this, we're just going to substitute it in. Right? If it makes a true statement, -4 minus 9, -13 less than 9, that's a true statement. So yes, it's a point on the coordinate plane. You do not have to graph these. When it says determine whether the point is a solution, just substitute it in. Okay, you try the next one. Go. Now check your work. -6 plus 15 is positive 9. Is positive 9 less than 9? No. If it had a less than or equal to, it would be a true statement. So 3, 5 is not a solution. And notice we put it in the ordered pair. Okay. Okay, now this is a little bit different in that they're giving us this graph, and we have to write the equation of a line. So the first thing we have to do is find the m and b. Okay, the b, the m, the b. There's 1, 2, 3. That b is 3. The m is rise to positive 2, and then run -2. So that equals -1. Okay? I could have gone up 1 over 1. So my m is -1. Now, I'm going to write this just like it's an equation. Y equals -x plus 3. Now, are the numbers shaded above or below 3? The numbers, are they greater than 3 or less than, where they're shaded on the y-axis? So if this is 3, this is 4, 5, 6. Since the numbers where they're shaded is greater than 3, we're going to switch this to greater than. Since it's dashed, I don't put the equal sign. We don't write that unless it's a solid line, and that's how we do the inequality. Let's see if my PowerPoint's better. Oops, they didn't even do it. I just probably grabbed this, and I don't know what I did with it. Anyways, that is our lesson for the day. Okay, how to write the equation of the line. All right, have a good day.